to lecture 9.2, serving and calling a ROS action. Creating an action server node is our first consideration. So, section 9.2.1, creating an action server node. Here are some key aspects of a ROS.py action server listed below as instructions for creating such a node. Step 1, import the Python package actionlib. So our usual Python package import call. 2, import the actions generated message types. So as we mentioned in the preceding lecture, when we create a new action definition and we do catkin make, several different message types are generated. And we can import them into our Python script or our ROS.py node by doing from the package name .msg. That's where the messages are created. Import action type action. So our action type in the preceding example was timer. So timer action, and then timer goal, timer result, timer feedback. So those are the 4 message types that were created in our example. But in general, the first word is the action type, and then the next word is action, goal, result, and feedback. Then step 3, define an action function to serve. So as usual, defining a function in Python, def, and then we'll make this action function do action. It could be called anything we like. And then the argument for it is a goal object. Okay. So, A, check for errors in client request and abort with result if necessary. So the client might request something that as the server, as the action server, we don't want to provide. So we can check what they are requesting, what the client is requesting. And if we don't like it, or we think that it's outside the parameters of what should be requested of this service, then we can abort, and we can set the results to whatever we think, and we can set an abort message as well. So that's the first thing to do. B, while the goal isn't yet met, so they requested an action which has a goal, while it isn't met, do the following in a timed loop. 1, check for a client request to preemptively abort goal and abort with result if necessary. So sometimes the client will cancel the request. So if the client decides I don't need that anymore, or it took too long, they might cancel the request, in which case it's called preempting. So if the client preempts the request, then the action request, then we check to see if that's the case, and if it's the case, then we will set preempted the result, and we'll set that abort message in return. If that isn't the case, so frequently that's not the case, the client hasn't canceled their request, then we'll set and publish the feedback. So feedback can be defined if we can create a feedback object with action type feedback. So that's creating an action feedback message, and we can define the field name. This is very much like a topic. Is a message, as were topic messages. We can set the field names. So as we created them in our action definition file, the feedback field names, in the case of the timer, we said that the feedback field names were time elapsed and time remaining. So we could do feedback.timeelapsed and feedback.time remaining and set them equal to some value. Okay, so that's what we're seeing here in this line, the set feedback line. And then server.publish feedback will allow us to send that feedback to the client there. So when the goal is met, we'll want to publish the result. So that's the setting the result, setting the fields of each result, which in our example, again, we had the outputs or results were time elapsed and time and updates sent. So we would want to set those in result and return it using set succeeded, the result, and the success message. Great. So step 4, register an action. So this is, as usual, we define our callback function first, and our action function is a callback function. So we set that there. We set that up first, and then we register an action below. So we use this action lib function, simple action server, and it takes 4 arguments. A string that is the server name, so we're defining what the server name is here, so whatever we would like it to be. Action type action, so this is the action message type, so for us it would be timer action in our example, but it can be any other action type action. And then action function, so this is the callback function we just described, do action. That was what we were describing in step 3 above, do action. And the last argument is actually kind of an artifact from older versions of ROS that has to stay around for legacy reasons, but we always want to set this to false. It's an auto start server functionality that's apparently not very stable, so the wisdom is to always set that to false. So we do so, and then finally we want to start the server. So start the server, and then ROS by spin, which gives us a sort of waiting for client functionality. Great. So next section, an example action server node. Let's implement our new action timer that we created in the preceding lecture. We need an action server node to do so. Create a Python node file. We'll call it fancy action server.py. Change its permissions and edit it to have the same contents as fancy action server.py. So let's take a look at what's in there before we do this in the virtual machine. So we're gonna bring in ROS.py as usual. For regular Python timing, we're doing this timer functionality for our action, which is not really something we would like to do, as I mentioned before, for ROS action or for timing in ROS. Really, we want to use rostime.sleep, rospy.sleep, rospy.rate. But for this example, we'll use the Python time package for regular old Python timing. And we need to bring in action lib, and then we need to import our action messages. So we've got timer action, timer goal, timer result, timer feedback. Those are the 4 message types. Here's our do timer action function, and it takes an argument of goal. So we'll start the timer, essentially. We'll initialize the count, and then we'll check the goal to see is the goal greater than 60 seconds. What we're going to say is we are not going to allow this timer to be set for longer than 60 seconds. So if the client requests us to, via a goal that has time to wait being longer than 60 seconds, we will abort and give the message aborted, too long to wait. Okay, so this is the first sort of check on the request that was sent to the server from the client to see if it's a satisfactory request to make. If so, as we expect most of them to be good requests, we'll enter this while loop, which is a timed while loop, and we set the timing using time.sleep. So we sleep for a second, and we go through this while loop over and over again. So this while loop will be the main part of the service of an action request. So while we're waiting to meet the goal duration, we want to first check to see, is the client requesting that we stop early? Like, is the client canceling its request for this action? And if so, we'll set results and set preempted. So we'll say that the state of the status of the action that was requested is that it was preempted, and we'll give the result the last situation, which was the time elapsed and update sent so far. So we set the results and we return. If the server does not have a request to preempt this action, so in the normal case, the rest of this loop will be the main thing that we'll be going through. And what we'll do is we'll create a timer feedback message object. We'll set the fields, so timer elapsed is one of the feedback objects, time elapsed, and then time remaining are the two fields. And what we can do is we can take the current time and we can subtract the start time, and we will then take that duration and return it via feedback in the fields time elapsed and then the difference time remaining. So when we're ready to publish the feedback, then we will use the publish feedback method, which is there, and then we'll update the count. We'll sleep for a second approximately using Python timing essentially, and we'll go back through the loop again. So each second we'll send a feedback message. We'll publish feedback message, which is what is the time elapsed so far, how much time is remaining so far, and that's the feedback. Once we reach our goal, so after the while loop finishes, we've reached the goal, then we set the result by creating a timer result object. We set the time elapsed using this field assignment, and the number of updates sent by giving it the update count, and then we set succeeded. This is our message, timer completed successfully, and the result is what we give to the set succeeded function as its first argument. So this is, of course, the do timer action function. All that so far was in that action function. The rest of this is what happens when we first set up the server, beginning before we have any requests, before we've got anything asking us to do timer. We have to initialize this server node, so that's what we'll call it, timer action server. And we'll create a server object using the simple action server function of action lib. We'll call it timer. We'll give it the timer action message type, and we'll do timer, and we always set the auto start to false. Do timer was our action function right here, do timer, and we're good to go. So now we can start the server, and then we'll wait for requests, for action requests. So that's how we want to write this. I'll just copy and paste the one from Rico Actions to my actions. I had to do a little tutorial demo version of this. So we can use ROS CD because we have already done our cat can make to the my actions package, and we'll bop down into source and see we don't have anything there, right? We haven't created any nodes yet. So we want to make this fancy action server node. So we can touch fancy action server.py, and we have to, of course, chmod u plus x because we want it to be executable, that file. And then if we edit it, it will be empty to start. We will then take the code that we just went through, select it, copy it, and paste it over. And we can save that. Okay, so we've created the fancy action server node under my actions. And we also would like to make a fancy action client node. And we'll want to chmod u plus x fancy action client. And we'll edit this. And we're going to want to add the contents of the fancy action client. Copy and paste this, and save this. So we've created both the fancy action server and fancy action client nodes. So if we ls, we see that they're both executable, they both have content in them. Before we actually run this, though, I want to go back over and take a look at fancy action client in more detail. We haven't actually talked about how to create a fancy action client node yet. Let's do so now. So creating an action client node. The key element to creating an action client node are, we have to import action lib. We need to import, again, the message types from our action definition. We want to define a feedback callback function. Okay, so whatever we want to do, so this is going to be in the client. So when the client asks for an action to be done, it will receive feedback, and whenever it does receive feedback, it will call this function. So it might, in our case, we're just going to print out whatever comes back as feedback. We might want to write that to a file. We might want to do something else with it. So the feedback, we can choose what to do with it inside the feedback callback function. Then we can register an action client and wait for the server connection. So just like we define a simple action server, we define a simple action client. We have to use the same server name that we used for the simple action server. And then again, the action message we'll give, and wait for server is to establish that connection. Step 5, send. Define and send the goal to the server. So this is how we decide what the goal is. We create a goal message object. Then we set the field names. So remember when we had our duration in the case of the timer action definition, the inputs were duration, time to wait. Okay, so in this case we can only set the time to wait for our goal. But if you wanted to set it to be something else, or if you wanted to have additional goals in there, we could add additional goals. So in this case, in our example, we can only set the time to wait as our goal. But in general, you can have any other goal included here in multiple fields if you'd like. Set them, and then you can send the goal with the callback function listed here. And then wait for result. So this wait for result is not going to finish until there have been hopefully several feedbacks feedback messages that have come in. So we will have called the callback function several times, and once the results come in, then we don't have any more feedback, and we can advance beyond there. So let's create a client for our new action timer. We already actually created this, and we copied the fancy action client file from the robotics book code example, which is here. So let's just go through this in a similar way that we went through the server. ROS pi, again time, action lib. All this is the same as in the server case. We have a feedback callback function, which all it does is it takes the feedback, it just prints. So we have two print statements here. We print the time elapsed as a formatted string and the time remaining as a formatted string. So we can get those fields using the time elapsed and the time remaining field calls of the feedback object. And the toSec method is something that is a method of a duration object. So a duration object has a toSec method on it, so we can call toSec and it will return the time in seconds. So the action client needs to, of course, have a node initialization. We need to create the simple action client. We need to make sure we use the same server name that was used in the simple action server in the server node, and then of course the timer action message. Wait for server, and then timer goal we set by creating a goal object, setting the duration to be 5 seconds. Okay, so the time to wait. And then if you'd like to, you can test out, so I would recommend running this first without testing out these aborts, but you can set the time to wait to be 500 seconds, which is, if the client requests 500 seconds, then you'll see the server abort this. It will say that's an invalid request because 60 seconds is the max we'll do. So we'll come back to that as the demo. Client send goal. So now that we've got the goal defined, we send it. We also give it the feedback callback function name. Notice that I called this the feedback callback. You can call it feedback callback if you like. I thought it was a little bit confusing because this has this is a named argument of the send goal, and it's called feedback callback, but you can call it anything you like, so the feedback callback or anything. So if you want to test out the preemption, sleep for 3 seconds and then cancel the goal. So this is another thing to do after you've tried it with those lines commented out. And then once the results come in, so we'll be getting some feedback that will call this feedback callback. So we'll get some prints, and then eventually, after we've waited for 5 seconds, the server finishes, it sends the results, we'll print out the state status, and if we do have results, which will happen in most cases unless there's an error, but there were some errors when I was debugging, so I put this if statement here. Then the time elapsed is going to print, and so will the update sent, assuming that we have results. So if the results were never set, this will be none, so it will say if there is something here, then we'll do this. If this comes back as none, it won't print these results. So that is our fancy action client. Okay, so now we've got those defined. And now let's define a launch file for this. So far in this class, we've mostly used ROS run and not made any launch files, but we did cover them early on, and I wanted to show how that would work for this case. So let's make a launch file for our action server and client nodes. Navigate to your My Actions directory and create a fancy action.launch file. Edit the contents and have those contents look like figure 9.3. So inside that fancy action.launch file, we want this launch tag, so open and close launch. We want a node tag here, which has 4 different properties. So name equals, we're going to call the name of this server node, the fancy action server node, server. We're going to call the fancy action server from the package my actions. Fancy action server.py is the name of the node, and then we're going to output to the screen. Okay. We'll also open up another node named client, which will be the my actions fancy action client node, and we'll also output that to the screen. So this allows us to avoid having to set up or to do a ROS core in one terminal and then open another terminal, source it, then do another ROS run, and then etc. So we can just set them all up to launch at once. You don't have to, when you do a launch file, you don't have to explicitly put in ROS core. You'll get a ROS core automatically when you launch. So it's kind of nice. It's a little bit nicer to work like this. So let's do that. Let's make this launch file here. So we are in my action source. We want to be in the package source, or the package root, which is here. So right alongside package.xml, the source directory, and cmakelists.txt. We want to create this touch. We're going to call it fancy action. Is it action or actions? Fancy action dot launch. Okay, so now if I edit it, then I can enter in launch node name equals server, package equals my actions, and node, what's the next one? Type equals fancy, in quotes, fancy action server dot py, the node name, and output equals screen, and then I want to end that node tag. I'm going to create another one that looks very similar, so I'll actually just copy the first one and paste it. And this was going to be called client, and it's going to be from the my actions package. Its type will be my action client, and the output will also be screen. So we have our launch file, and I think we should probably build and source now, because we haven't built since we added new nodes, so we should do so. So we should cd up to the ROS workspace level, and then we should cat can make. Great. So now we should be ready to actually do the ROS launch. So let's source this workspace. So devel setup.bash, and now let's do ROS launch, and we need to find our package, which is my actions, and then if we just tab twice, there's only one launch file, so it finds fancy action.launch and enter. What we see happening here is the ROS core gets launched. We see that this server and the client launched, and so the core service was ROS out 1, the server is server 2, and the client is client 3. And then we see the feedback start rolling in. So time elapsed, so it does it immediately. So the very first time through, it's very little time has elapsed, and there's a lot of time remaining. And then the next feedback is about 1 second later, which is about 1 second, with about 4 seconds remaining. 2 have elapsed, 3 remaining, 3 elapsed, 2 remaining, 4 elapsed, 1 remaining, and then it returns with the status timer completed successfully. Time elapsed total was a little over 5 seconds, and it sent 5 updates. We do have a warning that happens. I do believe that a feedback is being sent at 5 seconds, and then we finish, and so the feedback gets sent right around the same time the result gets returned, and so that's where we have this this little warning that shows up. It's not a big deal. If we wanted to debug that, we probably could do so without too much trouble. But the client finished cleanly, and now we have this rospy.spin going on, so it's going to wait. The server is going to wait for more requests for actions, but we can just Control-C to kill it. So it'll shut down everything. So the ROS launch was actually really nice to use. We didn't have to make three different terminal windows, source 3 times, and do the ROS run each time. So that was the example. I did want to mention at the end of this section here, at the end of this lecture, we have the more ActionLib documentation. We've used several of the API functions from ActionLib. So if you want to look at the details of the ActionLib documentation, there's the package sort of URL that you could go to on Wiki ROS. There's also Simple Action Server and Simple Action Client API instructions here. If you want to look at some of the more detailed API functions that are available, I'd recommend checking out these 2 pages. It's worth it just to see kind of what there is. There's some nice examples on there, and I think it's a useful thing to kind of be aware of what else is available for creating actions. So that's all I've got for actions. Have a good one.